Hi friend, welcome to PLANTI.com. Today I am going to demonstrate peptide bonds and Ramachandran plot in biochemistry. Peptides. Peptide is a compound consisting of two or more than two amino acids. Two or more than two, 3, 4, 5, etc. amino acid. Dipeptide, when two amino acid molecules are linked through a peptide bond. Two are linked, two amino acid, 1 and 2. This is dipeptide. And when three amino acids molecule are linked by two peptide bonds. Here one peptide bond, but when three amino acids are linked, then two peptide bonds, 1, 2, amino acid number 3. When three amino acid linked to peptide bond, that tripeptide. Example, this is example here, aspartame. Dipeptide example, aspartame. Two amino acid, aspartic acid and phenylalanine, D and F. This made aspartame, and it acts as artificial sweetener. It is 200 times more sweeter than sugarcane. And tripeptide, that's example GSH, glutathione. Glutathione made by three amino acid ECG, E, C and G. Two peptide bond, and it acts as an antioxidant. When two, more than 2 and less than 20 amino acids are linked by peptide bond, that's oligopeptide. Here 2 or more than 2, 3, 4, 5, 6, 7, 8, there are 20 amino acid can bind here by that's called oligopeptide. And its example, hormone. Any hormone, oxytocin and vasopressin, two hormones are made by 20 amino acids. This is oligopeptide. And polypeptide, when more than 50 amino acids are linked by peptide bond. Example, insulin hormone. 50 amino acids are linked here, that's called polypeptide. When 2 are bond, that's called dipeptide. When 3 are bond, that's tripeptide. When 4 are bond, that's tetrapeptide. When 5 are bond, pentapeptide. But when more than 2, 3 to 10 amino acid, that's also called oligopeptide. And when more than 50, that's called polypeptide. Then peptide bond. Peptide bonds are amide linkage formed between alpha amino group of one amino acid and the alpha carboxyl group of another amino acid. That means it bond between NH2 and other amino acid, COOH. These two are doing bond formation, that's peptide bond. How it create a bond? Here the reaction is dehydration reaction. Here you see carbon NH2, here one H removed and COOH, one OH removed here. So H2O, 2 hydrogen and 1 oxygen removed, and here carbon. So here NH and CO, that's doing bond formation, and one H2O removed, that's why The reaction is dehydration. Dehydration. One hydrogen remove. The H a water molecule is removed and the linkage amino acids are referred to as amino acid residues. Peptide bond formation is an endergonic process, and here del G is equal to 21 kilojoule per mole. Kilojoule per mole. Here you see peptide bond formation process, how it create a bond. Here carbon atom present here. Here two amino acid. This is one NH2 C COOH COOH group, NH2 group, hydrogen and hydrogen. This is structure. Which structure it is? It is glycine structure, and it is NH2 COOH HH. It also glycine structure. These two are doing bond formation. How it? COOH, here one OH remove, and here NH2, here one H remove. So H2O remove, here H2O remove. And how? Now present CN doing bond formation. This is peptide bond. And here C double bond O and NH, it also present here. C double bond O NH. But here when one mole or 1 unit of H2O when removed, it create a bond C and N. This is peptide bond. Okay. Then properties of peptide bond. What is the property? You see here. Peptide CN bond has a partial double bond character. It is not fully double bond. It is partial double bond character. Okay. It is partial double bond character. It is rigid and planar and prevent free rotation around the bond. It is not freely rotate, this bond. If it is single bond, it can freely rotate, but it is double bond, and it is 40% double bond character. It shows 40% double bond character. Maximum absorbance 190 nanometer. CN distance in peptide bond 1.32 Armstrong. Is to trans ratio is 1:1000. Trans configuration is more stable. Trans configuration is more stable and common than cis configuration. What is trans configuration and cis configuration? When R group here and R group here, two opposite side. Here R group here, here R group here. It is trans. Here. But when it is R group is present in same side, that cis condition. When opposite side, it is trans condition, but when it is same inside, that cis configuration. Okay. Steric hindrance is more in cis configuration. Steric hindrance, here R and here R, it doing steric hindrance nature. Then trans, because here are no steric hindrance, here more steric hindrance in cis configuration, because between R groups in same site. Torsion angles. Here C alpha present, here R group, here C O, and here create a bond formation because one H2O here removed. Two amino acid and here one H2O remove, and it is now amino acid residue. Here C and alpha, C and N, its bond formation, it is peptide bond. And here some name, here you have to remember the name. Here omega rotation, here phi, and here psi. How remember it? What is omega, what phi, and what psi? Because C and C alpha carbon, C, that's why psi, and psi, its opposite side, NC, that phi, and omega, it is the CN bond. Clear? C here, that's why psi, and the other side obviously phi, and Cn is omega rotation. 3 rotation here. And it is rigid and planar. It is peptide bond. Okay. This phi and psi easily rotate, but this CN bond, peptide bond, it is restricted to rotation. Restricted to rotation. In Ramachandran plot, biophysicist G.N. Ramachandran constructed a space-filling model of peptides and models of peptides and made calculation to determine which value of phi and psi are sterically permitted in polypeptide chain. Here, the white region are not permittable region, because here sterically hindrance site are present. This is not. But this colorful side are yellow, red, these are permittable region. And Ramachandran plotted it. Here psi and here phi. This is the x axis and this is the y axis. So here in this side positive, negative, here negative, here positive, because it is y and it is x. Ramachandran plot experiment here which are present in permittable region. Here present experimentally proven that here present antiparallel beta sheet, here parallel beta sheet, and here collagen triple helix, and here right twisted beta sheet, here left-handed helix, here right-handed alpha helix, this type. Here Ramachandran plot of D and L amino acid. Naturally we read L chiral amino acid, but sometime it also given a question D chiral amino acid. Here you have to cross acid here and here. Beta sheet come here and left alpha come here and right handed alpha come here. So overall structure is that here right handed come here and left handed here. You cross acid it in this type here, opposite side, and this is D chiral. Okay, thank you for watching my class. Hopeful the video going helpful for you. Thank you.